Am I audible to both of you?
Yes, sir.
Okay. So, uh, Mamuddin, these questions you have got in the test, right?
Yes,
In the
sir.
last class, these 5 questions. You were able to only solve the fifth one, right?
Yes, sir.
You were not able to define the molarity.
I was able to define.
Okay, but fifth is the only correct answer. Uh, where did you solve it?
Sorry, sir.
Where did you solve it? Did you solve it and send it to the coordinator?
Yes.
Okay, I will get it. Just hold on a minute. Uh, Austin, are you there?
Yes, sir.
Okay, so Austin, have you studied this chapter solution before, or you were just starting?
I'm just starting. I haven't studied this.
Okay, so I'm just gonna give you the overview of a concentration term, that is normality, and then we will start. Okay, see, normality is a concentration term in which we express solute or solvent. Now, before normality, you have to understand okay. So before normality, you have to understand gram equivalent. It's just like number of moles, and before gram equivalent, we have to know equivalent weight. See, what is equivalent weight? Equivalent weight is equal to molar mass upon x. So, Austin, do you know what is equivalent weight?
Sorry, sir. Your voice is breaking, sir. I
Yes or
can't.
no?
Your voice is breaking, sir. I can't hear you properly.
Wait a minute, just let me switch off my video. Okay. Can you solve the molar mass? Like, what is the molar mass of H2SO4?
Uh, MB, that formula.
Basically, molar mass is sum of all atomic mass in a molecule.
Yes, sir.
So, do you know what is the mass of hydrogen? One it is,
One.
and there is two hydrogen, so you are going to multiply it by 2. Then plus, what is the atomic mass of sulfur? That is 632, and there is only one, so you are going to multiply it by 1. Plus, what is the atomic mass of oxygen? That is 16, and you are going to multiply it by 4 because 4 oxygen is there. And now simply you are going to simplify it, and you will get the molar mass. So if you know the atomic mass, you can easily calculate the molar mass, right?
Yes, sir.
So do you know the atomic mass of 1 to 20 atomic number, like hydrogen to calcium?
I don't know, sir, but I'll study it.
Okay. Is my voice lagging?
Yes, sir. But it's
Okay, it will be all right for a while. Wait a minute. Concentrate here, please. Is my voice still lagging?
It's better than before.
Okay. So this is how you calculate the molar mass. Now I introduced a formula: equivalent weight is equal to molar mass upon X. So this molar mass you can easily calculate, and X is basically your valence factor. And all we need to do is to calculate valence factor. How we are going to calculate valence factor? So this X is divided into three parts. If it is an acid, if it is a base, and if it is salt. So if it is an acid, X is equal to number of H plus given. Like HCl will give only one H plus, so it has a value of X that is equal to 1. For this, X is equal to 1. H2SO4 will give 2H plus, that's why its value of X is equal to 2. And equivalent weight of H2SO4 will be equal to molar mass upon 2, because X will be equal to 2 and 98 upon 2. So the equivalent weight of H2SO4 will be equal to 49. Is that clear?
Yes, yes, sir.
Now, if it is a base, you need to concentrate on X. X will be equal to number of OH minus given. Now you can see this NaOH will give only one OH minus. So for this NaOH, X will be equal to 1. So equivalent weight of NaOH will be equal to molar mass of NaOH, which is 40 upon 1. So equivalent weight will be equal to 40. Again, you can see MgOH hold twice. It will give 2OH minus. So the value of X will be equal to 2, and equivalent weight will be equal to molar mass upon 2. Now, if it is salt, NaCl, then X will be equal to, NaCl is an example of salt. X will be equal to either total positive charge you can take or total negative charge. So if you are going to dissociate it, then you will be looking at this Na plus Cl minus. You can take on any one of them because they will be numerically equal. So equivalent weight of NaCl will be equal to molar mass upon X. X is 1 because positive, you can see only +1 is charge or -1. You will take only the number 1. Like this is also a salt. So if you are going to break it, you will get Ca plus 2 and CO3 minus 2. So equivalent weight will be equal to molar mass of CaCO3, which is 100 upon 2, because you can take any one of them, either negative or positive, both will be equal. So this is how we calculate equivalent weight. So I'm gonna write the formula again of equivalent, and that is equivalent weight or mass is equal to molar mass upon X. Molar mass upon X. So if I'm going to give you calculate equivalent weight of following, what you need to do? First, you are going to calculate the equivalent weight of Na2CO3. Then you are going to calculate the equivalent weight of Na2SO4. Then you are going to calculate the equivalent weight of NaHCO3. Then you are going to calculate the equivalent weight of H3PO4. Then BC, and this is your D, and then E. H3PO3, and then comes your Sp2. I'm going to write the atomic mass here. Sodium has an atomic mass 23. Hydrogen has an atomic mass 1. Carbon has atomic mass 12. Oxygen has atomic mass 16. Sulfur has atomic mass 32. Phosphorus has atomic mass 31. And all is covered here. So I'm going to just explain one of this and then you are going to calculate it. So as you can see, equivalent weight has a formula that is equal to molar mass upon X. So first of all, you are going to just wait a minute. First of all, you are going to concentrate on molar mass. I'm going to solve the A. Molar mass of Na2CO3. So as you can see, molar mass of Na2CO3. Sodium has atomic mass 23 into 2 plus 12 plus 16 into 3. So it will be 46 plus 12 plus 48. And if you are going to solve it, you will be getting 106. So the molar mass is 106. And now you are going to see Na2CO3 is a salt. So if you are going to dissociate it into ion, Na++CO3 -2. And there is 2 Na, so I'm going to put 2. So total positive charge, if you are looking at it, will be +2 because Na has +1 charge and 2 Na is there. So +2 and total is negative -2. So you are just going to take 2, either positive or negative, they will be equal. So equivalent weight of Na2CO3 will be equal to 53. Is that clear? What you need to do, it's very simple. Calculate the molar mass divided by X. If it is an acid, you are going to see how many H plus it will give. And if it is base, then you are going to check how many OH minus it will give. And if it is a salt, then you are going to dissociate it and it will look, you will look at total negative or total positive charge. They will be equal. So in this way, you are going to solve the B, C, D, E, F part. Will you be able to solve it on screen?
Yes, sir. Answer.
Okay, just let me know if you have any doubt.
Yes.
Are you done with the B?
Yes, sir.
Any answer? What is the answer
For
for
B,
B?
I got 71.
Same, sir.
Yeah, B. What did you just say?
71.
Very good. I'll just turn off my video because the net is quite disturbing. For C, any answer for the C?
84.
84 is the molar mass or the equivalent mass?
Yes,
See, I'm
I'm
going
the
to
only
explain.
one hydrogen ion. That's why I took one.
No, you should. NaHCO3 is a salt. So you are going to take total positive or total negative charge. So NaHCO3, if you are going to dissociate it, it will be converted into Na plus or H plus and CO3 minus 2, right? Both of you. Total positive plus 2, total negative minus 2. Equivalent weight, molar mass upon X. Molar mass is 84 and X is 2. It is a salt, so we will treat it as a salt. 42 is the equivalent weight of NaHCO3. Now, just listen to me. Uh, will you be able to calculate molar mass? So I would suggest you to calculate only X for D, E, and for F. You are going to calculate only X because it will only take you time for the molar mass. You can easily calculate the molar mass, right? Some of all the atomic masses in a molecule. So please do let me know about this X. What is the value of X for this? This is an acid, phosphoric acid, phosphorus acid. This is also an acid. Should I move? Okay, let's see. I'm going to explain because this 3 is very important. H3PO4 has a value X is equal to 3. H3PO3 has a value of X is equal to 2. H3PO2 has a value of X that is equal to 1. Basically, this is an acid which gives, this will give you 3H plus, this will give you 2H plus, and this will give you 1H plus. That's why the value of X is 1 to 3 or 3 to 1. Now, how I'm going to justify it? So I'm going to justify this with the help of a structure of this. This H3PO4 has a structure this, and this has a structure this. This structure is very important. When we are going to cover P block, we will be covering the structure of all oxo acids like oleum, sulfuric acid, SNO3. Okay. Now see, as you can see, this will have delta positive, this will have delta negative because the electronegativity difference between oxygen and hydrogen is very high. Oxygen is the second most electronegative element after fluorine. And if you are going to dip this in water, water is also polar and this bond is also polar. Why water is polar? You can see again in water H2 is there and there will be positive and there will be negative. Again, there will be positive and there will be negative. Due to this electronegativity difference, this bond is also polar. And always remember, light dissolves in light. That means this is your polar. Polar that means charged molecule, and non-polar that means uncharged molecule. That means there is no charge in the molecule. So polar solute dissolve in polar solvent, and non-polar solute dissolve in non-polar solvent. So as you can see, this bond is polar. All the three bonds is polar. So it will be giving all the three H plus in the water. And that's why the value of X for H3PO4 is 3. Now, when you come to this both are polar. And hydrogen is not that much. That's why it doesn't dissociate and it will give you only 2H plus, and hence the value of X will be equal to 2. Again, you can see this will be broken, but this cannot be broken easily. But this cannot be broken because the polarity in this bond is not that much. That's why it gives only one H plus. That's why the value of X is 1. Are you getting my point, all of you? Both
Yes,
of
sir.
you? Austin and
Not really, sir.
Mahmoudin. So it's very easy. Not really, sir. About which? This one, or this one? Everyone.
The first one only, second, third, okay, I got it.
Okay, see. Polar solute. You know that solute dissolve in solvent. So polar solute plus polar solvent. If you have solvent that is water and a solute you are going to take which is polar like this, so it will be dissolvable, it will be soluble. So what I told you here, I just proved that this OH bond is very polar. This OH bond is quite polar. So it will be dissociated in will be released. All the three H plus will be released, and we you get X is equal to 3. But when you come in H3PO3, only 2OH bond is there, and these are polar, so it will give 2H plus. But when you are going to talk about this pH, it will not be dissociated because it is not that much polar. It is not that much polar. Are you getting my point, Muhammadin?
Yes, yes, sir.
In the same way, this both will not be dissociated. It is not that much polar, but this is quite polar, so it will be dissociated, and H plus will be given by this. So these three compounds is very important in terms of equivalent weight. Just let me know when you are done with this so that I'll be able to move to the next one. Let me know when to change the slide.
Okay, done, sir.
Okay. Austin, are you done with this?
Yes, sir.
So we just know how to calculate equivalent weight. Equivalent weight is equal to molar mass upon X. And X you can easily calculate. If it is an acid, you need to see how many H plus it really gives. If it is a base, you need to see how many OH it gives. That will be equal to the X. And if it is a salt, then you need to see either total positive or total negative charge. So we are done with the equivalent weight. So the next point is number of gram equivalent. Number of gram equivalent. So Are you aware of this number of moles? Number of moles, if you have remembered from class 11, is equal to given mass upon molar mass. This is the formula of number of moles, one of the formula. Now, number of gram equivalent is also just like same in numerator, given mass upon equivalent mass or equivalent weight you can write. This is very important. Number of gram equivalent is equal to given mass that will be given in the question, and equivalent mass to look at. If you will read the question, you will get the compound like H2SO4, CaCO3, and with the respect to the compound, you can easily calculate the equivalent mass. Let's take an example. If you have given 4.9 gram of H2SO4, calculate equivalent mass. Calculate equivalent mass. See, what is the difference between this mole concept and equivalent concept? Actually, we deal in physical chemistry, we generally deal with the mole concept. That's why it looks easy. That's why it looks easy, and we are aware of this mole concept. Mole is equal to given mass upon molar mass. You can easily apply in one step. But when we are going to talk about equivalent concept, this equivalent concept generally we use very less, very lesser than this mole concept. That's why it looks tough, and also it has one more step than the mole concept. But the fact is that if you are going to learn this equivalent concept, it will be very easier to calculate your answer than the mole concept. Because in mole concept, you need to balance again and again, but in equivalent concept, you don't need to balance basically. So I'm gonna show you. As you can see, wait a minute, calculate gram equivalent. You need to calculate gram equivalent. Number of gram equivalent has a formula given mass that is given. I'm going to direct apply the formula. Number of gram equivalent is equal to given mass, that is 4.9 upon equivalent mass. So as you can see, I'm going to apply the formula. I'm going to calculate the equivalent mass, equivalent weight or equivalent mass of what? You can see equivalent mass of H2SO4 you need to calculate. So equivalent weight or equivalent mass of H2SO4, which will have a formula, molar mass upon X. Now, what is the molar mass of H2SO4? Initially, we calculated 98. What is the value of X? Now, this is your sulfuric acid, and sulfuric acid, it has two hydrogens, so it will give 2H plus generally. So you will get 49. 49 is the equivalent weight. So you are going to put the value 49 here and going to just solve it, simplified, removing the decimal, and again 1 by 10, that is equal to 0.1 gram equivalent is your answer. 0.1 gram equivalent is your answer. Is that clear?
Yes, sir.
You know what? If you will look at the number of moles, given mass you just need to write, and molar mass you just need to write, and you will get number of moles. So it is in one step, but this is in two steps because you need to calculate equivalent mass as well, which has a formula, molar mass upon X. Now I'm going to give you another question. .1 gram of Na2SO4. Calculate gram equivalent. Please do it. Any answer?
0.1 GM equivalent.
Okay, Austin, what about you?
So I'm doing the same.
Very good. That means you have got the right answer. If I'm gonna right? Equivalent weight, you have got 71. 0.1 gram equivalent. Now we are able to know, now we know about number of gram equivalent, and also we know about equivalent weight. Now we will talk about normality. Now we will talk about normality. Normality, we represent it by capital N. I'm going to define it first. Number of gram equivalent of solute per unit volume of solution in liter. Solution in liter. So here you can see normality N is equal to number of gram equivalent of solute. We can easily write a formula from this definition upon volume of solution in liter. Volume of solution in liter. So what I want to say is that this normality, as you can see, has a formula in which number of gram equivalent will be in numerator, and make sure that when you are going to apply the formula, the volume of solution must be in liter, and hence the unit is, you can see, in numerator it is gram equivalent and in denominator it is liter. So either you can write gram equivalent per liter, or you can directly write capital N. Like if you have got 2 gram equivalent per liter, you can directly write 2N here. Is that clear? Please do write it. Then it's just a step by step. Normality, for normality, you need to calculate number of gram equivalent, put the value here, and whatever is the volume given, convert it into liter. And let me know when you are done with this.
Done, sir.
Now I'm going to give you another question. 10 gram of CaCO3 present in 250 centimeter cube of solution. Calculate Normality. Austin, will you be able to convert this centimeter cube into liter?
Yes, sir.
Okay. Calculate normality. Just wait a minute.
Sir, I'm getting 200.
What did you just say?
I'm getting the answer as 200.
200 what?
I don't know the unit of normality.
Oh, you should know 200 m or 200 gram equivalent per liter.
Okay, sir.
Any answer from Austin? I'll just
Still doing,
explain.
sir.
Okay, I'm gonna explain it. Just focus here. Here the mass is given mass of solute, that is your CaCO3 is your 10 gram. It is also given that volume is 250 centimeter cube. And now we need to calculate normality, which has a formula, number of gram equivalent of solute number of gram equivalent of solute upon volume of solution in liter. Now, you know that for number of gram equivalent, you have another formula, that is given mass upon equivalent mass. Equivalent mass. Given mass is given as 10, and equivalent mass you can easily calculate. For equivalent mass, there is but only the step increases, which is a formula molar mass upon X. Molar mass of CaCO3, if you will calculate, you know, this has a mole atomic mass 40, this has atomic mass 12, and this has atomic mass 16. And if you are going to calculate it, you will be getting 100. And X will, since it is a salt, if you are going to dissociate it, you will get 2. So 50 is the equivalent mass. So you are going to write 50 here, and then you can see the number of gram equivalent that you have got is 1/5. And volume of solution in liter, 250 centimeter cube it is. So I'm going to divide it by 1000 to make it in convert it into liters. So it will be 1/5 into 1000 upon 250. 1000 upon 250, and then you can see this and this will be cancelled, and this will be equal to, and then you can see the answer will be 4/5. That means 0.8 gram equivalent per liter, or N directly we can write. Okay. Is that clear?
Yes, sir.
Please do write it and let me know. Mom, you didn't perform well in the exam. Just wait a minute.
Done, sir.
Just wait a minute. I'm just downloading the paper. Are you able to see a new screen?
Yes, sir.
Do you remember what is the answer that you have written for this one? That is good. A molar solution, that means 1 mole, basically 1 molality. This is 1000 gram, that is good. Now see, the sum of the mole fraction of all the component is unity. That is good. Yes or no, Humam?
Yes, sir.
And it is temperature independent. So the you have written the answer is B, but it is what? C. Assertion is true. This is your true, and this is what? This is your false. Are you getting my point?
Yes, sir.
Now the next question that you have calculated 0.5, 7 gram of nitrogen. As you know, nitrogen exists in N2 form. So the molar mass will be 28. So it will have 1/4 moles, and again 8 gram of oxygen. So 8/32, because oxygen exists in O2. So 1 oxygen 16, 2 oxygen 32, 1/4. If you are going to calculate the mole fraction of oxygen, Number of moles of oxygen 1 by 4. Then 1 by 4 plus 1 by 4. What you will be getting? 1 by 4 upon 2 by 4. That is equal to 2 to the 4 like this, and 1 by 4 into 2 upon 1. Okay, 0.5 you have written, but according to the what you have written 0.5, right? It is correct, right?
Yes, sir.
That's good. And for the you didn't solve this.
No, sir, I couldn't understand this.
See, the first of all, the formula is also given. Molality you need to calculate. Molarity here is given. What you needed to do is 2.05 into 1000 upon 100 into 1000 into density is also given this much. So 1.02. Then minus mole. This is your molar mass. So there is acetic and there is water. So you are going to take the molar mass of acetic water and then minus, you can see, m into mmb. Then you are going to take, this is your mb and this is your m. Are you getting my point?
Yes, sir.
And then you can do that. This is also correct. Very good.